the deployment that I'm talking about is actually Cerner. So as you know, we bought Cerner. It's a large company, has been around for a number of years, has a very large install base, both cloud-based, on-premise, thousands and thousands of customers, more than 1 million users of it, and a lot of applications. And when they came into Oracle, obviously we wanted Cerner to move over workloads to OCI. And for such a large company, that actually meant that they had to deploy or had to move over 300 applications to OCI. That while they have a large global customer base, they were using multiple data centers, both owned by Cerner and third-party clouds. They have like 650 physician users and over 2 million end users. But the deployments are not only on their own cloud or their own data centers. It's also on premise, like in hospitals, right? And these applications are mission critical. They're health applications, so they need to be alive all the time. That poses a couple of challenges. And we went over with them beforehand what that meant. First of all, it's critical that these applications are being monitored because they need to be alive 24/7. Because of the time that the company is already doing this, like over 40 years, they have a wide range of technologies and deployment types. So it's not just one application that's moving, it's multiple, and vary a lot in terms of technology. Because of the time, they also had like legacy monitoring solutions that were not all connected. Different LOBs had different settings on how they do monitoring and standards that they adhere to. And because of the presence in multiple data centers, it wasn't just a single shift, right? They wanted to lift and shift their workloads, but then it all has to come together to one single model. And we've chosen to kind of talk about the lessons that we've learned here and the tricks and the tips that we would have for other customers, because I don't think Cerner is that unique. It's like many customers or many companies struggle with. You've got monitoring that's supplemented over the years. You've got some in-house tools that were created before the business or the industry actually evolved to like observability standards. Some new applications were moved to the cloud. Others were still legacy on-premise. It's a charter that I think many companies run into. So we try to kind of do a summary of the challenges they faced and the tips that we would have if you go on the same journey, whether that's with 300 applications in such a large footprint or whether it's one application that you want to bring over. We talk to them from an observability and management platform view, right? It's a set of applications or a set of services that runs on OCI. It uses native tooling like notifications and the standards that are there in OCI in terms of security compartments, policies. Everything is integrated into a single platform. With these services, we can ingest all telemetry types. And today we'll be focusing in our tips and tricks on application performance monitoring and stack monitoring, but it basically applies to everything that we do in the O&M platform. Interesting to, or important thing to say here is collecting that telemetry data. We don't really care whether that's running on Oracle Cloud or a different cloud or on-premise. The data or the observability data can be collected from anywhere. So if you have a legacy application that's on-premise, you can still monitor it. If it's on OCI, that's fine. You can still get the same data types. Just as a very small introduction to application performance monitoring, key capabilities that we have. We do service monitoring, so your microservices, legacy monolithic applications. Real user monitoring, everything that happens on the client side. Security monitoring, availability monitoring, and infrastructure monitoring. And all of these will be discussed. We'll have some stories around them. But the important thing is that all of this data collection happens in different topics, but on the back, it all ends up in a single analytics environment, which allows you to do reporting, alarming, diagnostics. So it combines all the functionalities into a single data store. First tip that we kind of discovered is you have to put your monitoring first. What we did with Cerner is we actually enabled the new APM solution even before they started moving to OCI, because we wanted to get some baseline, right? We wanted to know how things worked, what the performance was, what the usage was, before they started to move over. Added benefit of that is that if you have it already in the existing deployment, you've got some baselines, but when you set up your new application environment, the target, in this case OCI, you can already detect issues and learn from the builds that are being created to test whether that's going to work. You've got developers that have access to the same data. So it kind of gives you a practice also with the solution before you do your big move. And at the back end of it, it's important because you can compare the before and after performance using consistent measurements, which means you have the same targets, you have the same baselines. Once you move over, is it better? Is it healthier? Is it consistent? Those are the things that you really want to measure if you do this kind of workload move. And the things that we focused on first with Cerner was real user monitoring, service monitoring. With real user monitoring, we basically mean end user monitoring. So we're tracking sessions, page views, AJAX calls that are being called into the application. And for them, we measure load times, but also network connections. Do we pass DNS quickly? Do we resolve SSL quickly? When you do an initial load of a single page app, it takes a little bit of time because you need to download the application by itself. But subsequent application transitions, do they happen quickly? Do you have issues somewhere? We focus on JavaScript error analysis. So we have the source code of the application. We map the errors, and we can actually tell you where in the application particular JavaScript is acting up, what the particular line of code is, so that it's easy for developers to troubleshoot and resolve. We have a dedicated browser agent, which you can just deploy using a couple of lines of JavaScript. If the application is built on Java or .NET, we have server-side agents that actually can take care of the JavaScript injection automatically for you. Makes life a little bit easier. We also focused on backend service monitoring, both for the microservices and the legacy backend middleware, where you see throughput, response times, errors. We do this dedicated with Java and .NET agents. You can also use open source, OpenTelemetry agents for all kinds of technologies that we do not directly have server-side agents for. And it also use it for profiling, to look deep into the executed stack, know where problems occur, in what line of code that happens, and where the bottlenecks might be. The second thing that we learned is about data enrichment. When you send over your telemetry, you might see like things like site IDs, or you see page IDs, which are not really the logic thing to report on. People that do not know your application that well won't know the ID in factual, like what it actually is. So you want to have like things like display names, that it's easy to consume the information. So you need to have aliases for dimensions and metrics so that it matches the terminology that you use within an organization. You're not talking about a site 3509, or you're talking about a site that is for customer X. right? You can use the data enrichment also to extract information, combine and calculate it with new attributes. An example of that is, for instance, AppDex, where you qualify the performance of a particular call, whether it's an AJAX call, whether it's a servlet call, whether it's a page that's being loaded in the browser. Based on patterns, you want to classify them as good, bad, or okay. And AppDex gives you one single metric back saying, okay, so many percentage of your calls or operations are in those buckets. But the important thing here is through data enrichment, we can say, okay, if it's a browser page load, I'm okay if it's 2 seconds. But if it's an update, just a partial update of a screen, it has to happen within 500 milliseconds. So you can set different thresholds based on the information that we're collecting, whether that's a servlet call again, or whether it's DBC, or whether it's a full page load on browser. Set different targets, but get back the same classification. Is it good, bad, or okay? And then across everything, you have a very consistent and single measure to put everything into reporting. Our agents are highly configurable and can do custom metrics and spans. The way that we do this, by the way, the data enrichment, is pretty neat. Out of the box, we have some span enrichment already. We resolve things like geolocation, where we map the IP address to a location. We do threat analysis. I'll get into that in a minute. If you have OpenTelemetry based agents, there's slight difference in terminology. Sometimes it's just capitalization of an attribute name. Sometimes it's a completely different name. So we do out of the box translation from OTel to APM. But you can also use it to map files to add business or app terminology. For example, when you have a URL and the URL says content ID 12345, if you know that that's actually the shop or the payment service, then you can upload mapping files that will do that translation for you. IDs to customer names, something like that. Error codes that might not be very readable or understandable for everyone, translate them. You can also do things like bucketizing or removing PII data. With bucketization, you might say, okay, based on these conditions, I would put this request into bucket 1, 2, 3, customer, gold, silver, bronze, whatever, right? The fun thing about this is that it happens at ingest. So you don't have to change your application to get these reports in the way that you want it. The data comes in. As long as you provide the rules in which we need to change the information that we're receiving through spans, you can get the reporting, any type of reporting that you want, without changing the application. And I think that's a big bonus, because it saves you a lot of time getting developers to all align and change a lot of application logic to do your reporting. Since this is as I said, Cerner has 2.2 million end users. It's a lot. There's a lot of big applications in there, which also means that the telemetry data is very huge. Couple of things that we learned in terms of volume handling. One thing is, first, observability as a source, right? Make sure that your instrumentation, the agents, are automated in the deployment cycle. When you deploy an app, whatever version, make sure that that agent is part of your code, so you don't have to manually or through automation add it later. Make sure that when you deploy it, whether it's for a development cycle or for a test cycle, that instrumentation is there and it automatically shows up in your data set. Local monitoring. We keep the APM instances, in our case, an APM instance, we call them domains. which basically is just a logical way to group data. We keep them in the same region as a monitor application. It just saves you having a lot of data transport, and also the risk if there is an issue with network connectivity. The internal network most likely still available, and you would still get the monitoring and the data collection done, versus something that has to travel from one data center to another. We're using sharding to monitor the data vertically, which basically means, I told you about like 300 applications. So within APM, we have a logical grouping mechanism, which is the APM domain. And it means that all the data, all the traces, all the spans get collected in that particular data set. It has its own dedicated tables. It has data separation, policy separation. It allows you to put data in a particular bucket without losing the option of reporting on it across different APM domains. But it allowed us to say, okay, if we have high volumes, we'll dedicate more database resources to a particular APM domain so it can scale out. So it's an important part of the setup. And then when you have a lot of data, if you ask questions in a large detail, like, okay, what's the session time per user over a period of time of 30 days, and you've got millions of users, then you have to go through like billions of data points. Doing that query might not come back in time, even however big the data store resources are. What we can do is schedule those in background queries, prepare the data so that you can use it in dashboards, in UI very quickly, because it's been prepared as a data set for you on a particular time frame that you need. The way that we kind of handle these things is through a very powerful trace query language. It allows you to select the data that you need. So filter it, use syntax to just select a bunch of spans or traces that you need. Do sorts, filters by attributes, but also perform statistical functions like plus of things, set the string or date, and then you can present it in table, geomap, or topology views. And we have stored action buttons basically in the Trace Explorer, where if you've created a query and you think that's something that other people will find intuitive to use, you can just store the query, make a shortcut out of it, and provide it back to any user that's in Trace Explorer. The same queries can then be used to create visualizations outside of the ones that are in Trace Explorer. So basically, you can create curated views for non-technical users, managers that need to look at the information, but maybe not have access to the trace query language. They need to find the results, but not be able to do the queries on the back end. A very important part of this is the prepared data, right? You can run these queries in the background so that if you have a dashboard that presents information that's calculated over a long period of time, the trends, it doesn't have to go to the raw data, it goes to the prepared data. And that means that you're getting very quick results, even over very, very large data sets. And we're talking here like millions of data events or spans being sent to us by the minute. So it's a very scalable solution. Besides having it in our UI, there's always access through APIs. And if you want to pull the data into a different reporting tool, like Oracle Analytics Cloud or something else, you can do this through the same interface using an API. And the fourth thing that we wanted to discuss is security is everything, right? You're collecting information about how your application operates, who's accessing it, how fast or how slow it's going, which errors are there. That can be sensitive information. So the fact that it's on OCI means that it's you can adhere to the same policies, the same access rules, but also the data that we're collecting, we can do pattern analysis so that we see suspicious patterns. Are there users that are coming from very many IP addresses, but only one username? Or is there some kind of high volume on hours that you're not expecting? We do forensic transaction analysis. So you can see for a particular user that you might have identified as a threat, what they did and what the impact was on the application. How far did they get into the application? And the way that we do it is we've integrated with the threat activity service within Oracle. That's actually a free service. It's basically a large data set that keeps track of malicious IP addresses, particular domains that are not trusted, bots, but also a large database of CVEs known on application libraries, right? What we do is when we see the data come in and we have the IP address of users, we check whether that IP address is known to that data set, and we provide labels saying, okay, this might be a threat. We're disconfident that by a number from 0 to 100, disconfident how the information about the threat is. And we classify things as bots or bad actors and tons of other labels. It allows you to see which users might be problematic on your application. It shows you which services within your stack actually were affected by such actors, by such users. We can see the queries that they did. Did they get as far as like execute a SQL on your application? But also important, we can see the affected resources, right? How many cycles in memory or network or host are being spent on just getting responses from bots, for instance. You might be spending a lot of resources on things that are not key to your application and that you might need to block from your application. We're also working on something. We already have the ability to report on what libraries are used. What we're adding now is if you restart the application or a library, that we live check it against the latest CVEs, so that we can give you alarms on, hey, there's actually a library being in use in your application environment that is using a library that has a CVE against it, so that you would immediately see what's going on or where the problem might be. So you can do the check now yourself, but the live check against an application that becomes live is coming very soon. Stop here and I'll give the word to Aaron.
Hello, everyone. I'm Aaron. I'm going to start off with availability monitoring. So what's kind of nice, I'm happy that I got this portion because availability monitoring is pretty close to my heart. And before Oracle, I actually worked for Cerner, and I had responsibilities managing their cloud identity solutions. And those carried very strict SLAs, as you can imagine. And availability monitoring let me know when customers were unable to access our login pages. And what makes this monitoring even better is that it's inexpensive, it's quick, and easy to deploy. One important thing about these is they should be placed generally everywhere. And what I mean by that is all levels of your application. Put this availability monitoring locally against the application servers themselves. Test against the private load balancer in front of your application servers. And finally, locally against the public-facing load balancer. But with all those local tests configured, the next step, make sure and configure those tests close to where your customer is accessing your applications. So in my experience, I had customers that were using an application located in the US, but we had, the application was located in the US, but they were accessing it from all over the world, Europe, Australia, just to name a couple. And you want to be able to put those tests there as well. That way that you have the same understanding of performance as your customers do. And one of my favorite stories having used availability monitoring was my team was able to identify slowness with one leg of an ISP, and we would have never had that without availability monitoring. So not only were we able to verify and validate their slowness that the customer was experiencing, right? Because all my local tests would have been just fine, but it helped us to identify exactly where that problem was occurring. All right, next. So availability monitoring is better known as synthetic monitoring. And this monitoring can include browser, REST, network, DNS, FTP, and even SQL monitors. When these monitors execute, they'll capture a HAR file, network traces, and screenshots for every single one of those test runs. The monitors can be configured both public and private vantage points, like I spoke about earlier. And public includes those OCI and external, while private is kind of within OCI, can also be within OCI and including Docker images. Synthetic tests can include custom in-script metrics as well that can execute whenever the synthetic test is run. And don't forget availability reports, because at the end of the day, we're all really concerned about our SLAs, and you need to understand that historical availability. All right, next. Don't forget the infrastructure. So infrastructure, again, I mean, not to reuse the term, but again, it's that essential, it's like the essential set of monitoring, right? And it gives you quick time to value with automatic host monitoring and a one-click discovery. It has out-of-the-box monitoring UI, so you don't have to sit there and go build every single view that you're looking for. It's just there as soon as you complete your discovery. Monitoring at scale allows you, monitoring all your resources in your environment at a single place. And it doesn't matter whether it's running in OCI, on-prem, another cloud provider, or all the above, right? Topology is super important. As you can imagine, it gives you that quick troubleshooting across the application stack. Because inevitably, if you are seeing database problems, you need to understand, is WebLogic and impacted, or is the host causing part of this, right? Being able to have that whole perspective of the entire application stack. And it's from everything from your storage to the load balancer and everything in between. Stay proactive with anomaly detection and extend monitoring to meet unique business requirements. And I'm going to touch on that here in just a second. Infrastructure monitoring allows you to quickly get answers to those, once again, essential monitoring questions. What's in my environment? Is everything up and running? Are there any performance problems? Am I running out of CPU, memory, or storage? And once again, what's happening across that entire application stack? Make sure to get started with discover your host and your database, and then that full app stack. Use the automated host monitoring. That's going to simplify your onboarding experience, just like it did for Cerner, in using automated host monitoring to prevent those monitoring gaps. Follow the prereqs and use the one-click discovery, right? When getting started, you always need to make sure to follow the prereqs. Everything's outlined in documentation. But for example, like EBS, you've got to make sure that the monitoring user for your EBS application has the ability to read the EBS schema, right? Otherwise the monitoring isn't going to work right. And then use that one-click discovery. Fill in the blank, hit the button, and it'll go discover the resource. And depending on the resource type, it's topology. Don't forget to import OCI resources. This allows you to consolidate all of that monitoring. Your storage and load balancers, right? Bringing all that into one place and then complete that application topology. You don't have to go and navigate over to the to the OCI infrastructure networking page, and then go search for the load balancer that you think is supporting the Tomcat, that you're trying to monitor, right? If you import all that into one place, then all of that topology allows you to easily go from, all right, my Tomcat's not getting any activity, but why is that? Let me look at the load balancer, and you just click a link instead of going searching. And then from there, follow the breadcrumb once again, those troubleshooting workflows to go dive in to figure out, hey, do I need to go adjust the pool? Did we forget to put this server back in load? Begin monitoring with the enterprise summary. Identify resources that are down across your environment and monitor by exception. And that allows you to identify performance outliers and drill down to those resource homepages. Again, it's that troubleshooting workflow UI. And I keep hounding on this, but it's so helpful to be able to navigate across that entire application stack using the topology. So manage alarms at scale. Define alarm rules best practice with monitoring templates. Now, monitoring templates will be out shortly. It will allow you the ability, we'll have a bunch of out-of-the-box monitoring templates for you. For say, let's use EBS again. For an EBS application, and that's going to include EBS itself, concurrent manager, forms mailer, all Oracle database, host, all of those best practices, right? All put into one template. It's a great jumping off point because getting started with monitoring can be overwhelming. And getting started with just a monitoring template gives you kind of that initial jump, get your toes in the water, right? Of monitoring. And then from there, be able to just clone that template and adapt it to meet your own your own unique business requirements. Don't forget to review and triage all open alarms within the enterprise summary. You're going to be able to see that overall availability of what's up or what's, but more importantly, what's down or not reporting. But we're also going to summarize all the open alarms. And in that summary, we're even going to give you the dimension and the current value of that alarm. So you're going to understand whether or not to go after a boot file system at 80% or a root file system at 99%. Your DevOps teams can prioritize that work. Then suppress notifications with topology-aware maintenance windows to eliminate alarm noise. And this is really, I don't know how I got in this place where this is fun, but I enjoy this. These are the fun things, right? Where it does cool things. Where maintenance of windows, this topology-aware maintenance window, where traditionally you've got to go create if you're going to reboot a node that has WebLogic and database on it, you've got to go put a suppression in on the availability for the host and the database and the WebLogic and the CPU and memory and all these other DB time or whatever all the metrics are, right? You've got to go put in all those individual suppressions and know that it has this Oracle database and this WebLogic server all on this host. But using the topology, you place one resource, a host, in maintenance, and it will automatically understand based on the topology all the resources running on it and all the alarms associated with those resources and place all of them in maintenance. And then you can schedule that to happen once a week. You can do it now when, if alarms are firing and going crazy and you need to focus, put that thing in suppression, and just say, put it for 2 hours while I'm working on it to get it back under control. There's lots of variability there. Don't forget to extend monitoring to meet your unique business requirements, right? Cerner, just like I'm sure every other organization, has their own homegrown applications that don't fit the traditional, Tomcat server or WebLogic server, et cetera, right? Absolutely, those are there, but there's also other things in there, right? So you can monitor custom applications using their process signature. And what I mean by that, like if we use Nginx, for example, you can go find and monitor the application, the program, Nginx, but you can also monitor independently the dimensions of that program, like its worker processes or its main process, and then monitor those for availability, CPU, memory, and process count. So it allows you to create custom metric or custom resources that meet your unique business requirements. Metric extensions. In my early days at Cerner, we had DBMS jobs. One example of this is DBMS jobs. And in DBMS jobs, I had a set of jobs that had to be run on specific cadence. I used metric extensions to go validate the jobs were there, the jobs were scheduled, and the jobs ran. Oracle would never come to me and say, Aaron, what's your best practices for running your custom DBMS jobs? We want to create a metric for you. That's while it would have been nice, that's not what would have happened. And so this gives you that flexibility to go create metrics that are just, completely different and whatever it is to help make, meet your unique business requirements. Now, some other fun ways to go do this is through Prometheus Telegraph and Collect D. Prometheus is there today, and that allows for an easy shift from, Prometheus, where it might be sent to another dashboard or whatever, to be rerouted to Stack Monitoring, where you can go and create your topology and get all the benefits from the out-of-the-box UI and start working with all the other pieces there, right? The monitoring templates, etc. And soon we've got Telegraph and Collect D to follow. So some key takeaways, right? Jürgen spoke about this first. Monitoring first. You've got to compare apples to apples, right? So in doing so, go configure what you want your monitoring standards. Go set that up before you begin a big migration. So get your monitoring defined, set it up. That way, as you migrate, you can actually do a like-for-like comparison against these metrics. It just gives you that reliability of the performance and data set, before and after. Now, I spoke on this a little bit as well. Monitor locally, right? Be able to do those health checks locally. Take the network and the ISP out of all of that, and as well as do monitoring in the same region. And yeah. So just make sure that you've got it locally. But I don't want to forget about, don't forget to monitor where your customer is, where your customer is accessing your application. Proactive monitoring, again, through availability monitoring and SLA tracking, those synthetic tests that I keep telling you about, those things were a lifesaver. Monitoring templates to standardize those best practices. Don't try and set it up onesie-twosies things. We all know that never works out well. Leverage monitoring templates to standardize that and reduce your overhead in managing and setting up alarms and maintaining alarms. Don't forget the entire stack. Once again, the load balancer, the application servers, databases, storages, network, you name it, transactions, all of it. Get that entire application stack, because if you forget one spot, history tells me every time that I've done that, that's where my problem ends up being, and I don't have visibility into it. And nothing's more frustrated than the customer telling you that they have a problem. You want to know before your customer does, so you can say, I'm already on it, right? Prepare dashboards. Now, we want to make sure that you build, make dashboards to meet those lines of business, right? There's your DevOps engineer who's diving deep into the logs or whatever that is going to have a completely different perspective likely than, your high-level management. So build dashboards to meet those unique lines of businesses, but also consolidate your melts, your metrics, events, logs, traces, and SQL. And even with dashboards, don't forget to use the troubleshooting out-of-the-box workflows as well, right? Those enterprise summaries and home pages and the topology that helps navigate you through that entire application stack.
Aaron, can I just
Please.
want to monitor locally, which I think is very important, and it kind of aligns with the broader Oracle strategy on cloud. The fact that we have this many data centers, that we have data centers in government clouds, right? That we have dedicated data centers. or even like on-premise data centers, they can run the same services. So all of this is available on whatever type of cloud deployment that you want. But it also means that if you have to comply with local rules, where data needs to reside and what the security and policy is around the data that you're collecting, we can meet all of this. I mean, all of the services are always available in what type of cloud deployment that you're using, which also means that you can comply with data sovereignty rules that are applicable for wherever you're residing. I think that's an important differentiator for Oracle across the board, but it also applies to all the O&M services.
Yeah, anything we can do to spread the word. So finally, we've got a lot of resources out there. Jürgen, myself, the whole observability and management team, including Catherine here, everybody does, we try and do as much as we can to be able to help everybody along, whether that's through documentation, release notes, or, YouTube videos, tutorial series on YouTube's, blogs, live labs. I don't know if I can't encourage you enough to go join some live labs, and it allows you to get in there, kick the tires, try things out without breaking anything in your environment, right? Do it in a controlled environment where you can go play, have some fun, and try out the product yourself. With that said, I don't know if there's anything else from Jürgen, or if there's some questions out there, we would love to answer them.
Yeah, I haven't been able to look up at the Q&A because I was sharing, but maybe you see some Q&A, or Catherine, do you have something on the Q&A?
Yeah, there's no questions in the Q&A, but it's open. So if you have a question, you can raise your hand or pop it in the Q&A.
Sounds great. Please try out the labs. There's a lot of different options out there for you to take those labs. But I really do think that they're a great opportunity for you to be able to get into our environment and go play around.
Okay, I see a question here. I'm trying to get Raymond. Yeah. Interesting. He might be, are you signed in as someone else? Because I don't see your name listed. Can you
feel free to post it on the Q&A. By the way, besides the
can you
live
type
lab,
it in the Q&A? Because I don't see you listed as an attendee, Raymond.
Besides the live labs, actually you can deploy APM as a free domain. It has limitations. It cannot process a lot of data, but if you have a development environment that you want to kind of try out, see what comes in and use the product, you can just do this. You can have an APM domain for free. It's always free. That just processes like 1,000 spans per hour. But it's great if you have a development environment and you just want to try out what would you be seeing, what diagnostics would you be getting. It's completely free forever. So do you have anything else, Catherine?
No, I don't see any more questions. There aren't any more questions. I'll give you back your time. Thank you so much for joining us today. That concludes our session for today.